So we are back again with another video on this topic operator, and today we will be discussing topics like bitwise operator. We will be covering some special operators, and we will also give some examples and programs. So we are back again to bitwise operator. Now what is this bitwise operator? First of all, we will understand what is bitwise operator and why do we call it bitwise. Bits means binary single digits. Like for 2 we have binary 0, 0, 1 and 0. Here every single digits are known as bits. For example, this is a 4-bit system. So bitwise operator is called as bitwise operator just because it operates bitwise, that is one by one bit. Every operation is based on binary numbers. So now what are the types of bitwise operators? Here, let me just erase it. Yes, now we have all total 6 bitwise operator. We will understand each one of the operator one by one. For now, just remember the names. For example, this one is bitwise AND operator, bitwise OR, bitwise XOR, bitwise Compliment, left shift and right shift. So now let's just move to each operators one by one. First, moving to the bitwise operator, first understand what is this OR operator, what is this OR operation, what is this AND operation, and what is this XOR operation. So basically these two are inputs which we give to the machine, that is our operator, and these are the outputs. This is a rule that is defined already and we just have to memorize it. For example, for 0 and 0 input we will get for OR operation we will get 0, for AND operation we will get 0, but for XOR we will get for XOR also we will get 0. That is all. Just like that we all have all these values. Now let's move to the OR operator. Here we have the rules now, and this one is the OR operation, that is the result we will get from OR operation. And let's just see few examples and understand what is going on. So this one is the first example. We have 2, that is in binary it is 1 and 0, 1 that is 0 and 1, and when we apply the OR operation we get 1 and 1. How? 0 and 1 we get 1, 1 and 0 we get 1 again, so we get the 1 and 1, that is 3. While programming, the output would be 3 if we do 2 or 1 operation. We will see the programs afterwards. Now let's move to the second operation, second example. We have a complex one, and that is 3 and 6, and yes, we are getting 1 1 1, that is 4 2 1, that is 6 and 7. We should be getting this 7 as output. Now yes, now the third operation, we have 12 and 25. When we apply the OR operation we get this one. So what is this one? We will see this answer afterwards in the programming section. Now let's just move to the explanation of bitwise AND operation. Again we have the rules here, and this one is the bitwise AND operation. And now the example 1, same problem, same numbers. We have 2 and 1 as the binaries, and then applying a AND operation, and we are getting 0 and 0, as 0 and 1 gives 0, 0 1 and 0 gives 0. Same goes for this one. We have 3 and 6 here, and we are getting 0 1 0, that is we have 2 as an output. Again here 12 and 25, we are getting an output here. So what is this number? We will again find this out by programming methodology. Now again we have bitwise XOR. Now bitwise XOR operation, we have this one is as the output, we have these two as input, and first example being this, and yes, we have again 2 and 1, which should get the output as 3 for XOR operation. Similarly in this one, 3 and 6, we will get the output as 5. Again this one is a complex one, we will find out what this number is in our programming section. So yes, we are back again to VS Code, and now first of all we will include standard.h and then int main. Yes, now we are ready to program our examples that we have discussed here in the previous section. So first of all we have OR operator. So first of all we will take two integer variables, int a and b, and then let's first take the first example, that is a is equals to 2 here, b is equals to 1 here, and then we will just print the value ampersand d, sorry for that, ampersand d, and then yes, now a or operation b, this is what we want to print. Now just we hit the run button, and then we should get the output as 3 as we have discussed here. Now let's just again change the values here, 3 and 6, and then again run it, we should get the value as 7. Yes, we have already discussed that. Now the question that we had that what will be the value of this one. So let's give the input 1 and 2, that is 12 here, and then here 25. So what the compiler is doing, compiler is first converting this a and b to binary part, and then it is performing the operation and then printing it in the integer type. So now let's just print this one, and we should get the output here. Yes, we get 29. So the answer for the OR operation of this part is 29. Now let's just move again to the AND operation. Now we will again take, just rub this on, and then we will take two variable again here, int a comma b, a is equals to 2, b is equals to 1, as for the first example in the AND section. Now we will just print the value, printf ampersand d, sorry for that again, and then yes, and then we will a and b, that's what we want to print. Now let's just hit the run button, and here we should get the output as 0. That's we have got here in the AND section. Now let's just change the value, that is 3 and 6, and then run it, and then we should get the output as 2. Yes, we got it again. Now for that question that we had asked ourselves, that is if the value of a is 12 and b is 25, what should be output? So again we will repeat here what the compiler is doing. Compiler is first converting the value of a and b to binary digits, and then performing the operation, and then printing it in the integer type. Now just run it, we should get the output here. Yes, we got the output as 8. So see here, this binary part is actually 8. Now we will move to the another part, that is XOR operation. Just print this, we will rub this one, and for that, and then again take two variable int a and b. I'm continuously writing this again and again just to make us familiar with this programming format. Now just we will assign the value a is equals to 2, b is equals to 1, and then we will write printf %d and then a XOR b. Now let's just print this one and see what we get the output. Here we got it 3. That is correct from our presentation that we have calculated theoretically. Now let's just change the value here. This should be 3, this should be 6, and then F6. Yes, we got the output as 5. This one is also correct. Now we will hit for the question and answer question section, that is 12 and 25, and again we will run it, and we got the output as 21. For the third question we have the answer as 21. So again there is a catch here, and that is these operators actually are interchangeable for the variables. And let me try to understand. Let us try understand by B XOR A is equals to A XOR B. Now let's just see that. We will just print F and then %d. We are just testing it. B XOR A. Is this right? Let's just run it. We should get the output as 21 21. That is, yes, this one is right. Same goes for the all other, that is and if we will run it, we will get the output as 8 8. For OR, and then if you will run it, we will get the output as 29 29. So it can be interchangeable. So now thank you. Let's just move to the presentation part. So we are back again to our presentation. So now we will be discussing about bitwise complement. So first of all, what is this complement? So in the binary we have two types of complement. The first one being 1s complement and second one is being 2s complement. For let's take an example of 2. The binary equivalent for 2 is 0 0 1 and 0. For 1s complement we will just make it reverse the in digits, that is for 0 this one will become 1, here 1 we will become 0, and again 1 and 1, and for 2 we will add 1 here, that is plus 1, and we will get 1 plus 1 10, carry 1 here, then 1 1 and 1. This one is the negative of 2. So now wow, what is this? So before the invention of 2s complement, the computer system uses 1s complement, and after after getting a flaw in 1s complement, the 2s complement was introduced, and then now 2s complement is used for the general representation of negative numbers. So first of all, let's see an example of these complements. We have 12 as our number. Now let's just convert it into binary, that this one is the binary for 12. Now inversing the binary, we get 0 0 1 1. This one is the 1s complement, and adding 1 to it we get this one, that is 2s complement. So yeah, this one is the 1s complement and this one is the 2s complement. In computer, that is in C programming language, if a number is, if we have a is equals to 2, then negative of a gives 2s complement, but negation of a gives 1s complement. The basic concept of 1s complement, that is bitwise complement, is this one. So we actually get 1s complement by bitwise complement. So now we will be studying shift operator. So what is this shifting operator? First of all, we will understand what is shift operator, and then we will understand what are these types of shift operator. So let's take an example of 2. Again we are taking 2. The binary equivalent of 2 is 0, 0, 1 and 0. So if we use shift operator, uh, if we shift using shift operator by two values, then shifting to left means this 0 will be here, this 1 will be here, this 0 will be here, and this 0 will drop, and again here a 0 will be added. So this is the operation of shift operator. Let's take an example of 3. We have 0, 0, 1 and 1. After shifting 2 towards left, what we get? If we shift towards left, that is this one, this is the left of shifting towards left, and this one is shifting towards right. If we shift towards left, we will get here, this one will be out, 0, 0, 0 and 1, something like that. Let's see an example of 12. If we write something like this, that is shifting towards left, that is this direction, and then we have example in the binary of 12, and then after shifting we get this one whose value is 48. Again we will use shift operator to another direction here, and then the binary of 12 is this, and when we after shifting we get this one, and after converting we get 3. Let's see the examples of shift operators and also the complement in VS Code. So we are back again to VS Code, and again we will start our programming by including standard io.h and then int main. Yes, now first of all we will take a variable, we will assign it to 2. This one is an example of, this first one is an example of complement operator, and here we will take a variable a with value 2 and then find the negation, that is 1's complement and negative of the number, that is 2's complement. Now let's just write this one. Yes, now let's just, we have taken a variable a that and whose value is 2 now. Now let's just printf %d negative of a. This will print the 2's complement. Now printf %d, this will print the negation of a, that is this will print the 1's complement. We will just write for convenience 2's complement, and then we will also use slash and backslash n, and here 1's complement, here also backslash n. Now let's just run it, F6. we should get two values, that is -2 and -3. So here you can see this was the problem with 1 is complement. We didn't get we were not getting the perfect output in the negative numbers. That's why 2's complement was introduced. Now we will just remove this part, and again now we will practice some examples for shift operator. So this one is an shift operator example. Now let's just take a variable int a and a value 2 here. Sorry for that. Okay, we have taken 12 there, so we will again take 12 here. So now let's just print $d a, that is left shift 2 with 2 values. So here we have understand what's going on in the theoretical part, and now see what's the output here in the practical part, and here we got the output as 48. So now we'll just remove this one again, and then we will take a value, and then a value is 12 again for the left shift. Now again we will use printf $d comma, and then we will just write a right shift with 2 value, and we will just check the output. We have already done the theoretical part here, and now here's the practical part. The output is 3 again. So you see, this is how the theoretical part and the practical part are matching. And now we will move to the next operator, that is some special operators.